Experimental probability. Okay, probability based on experimental data or observations is called experimental probability. The probability of an event is equal to the number of times the event occurs out of the total number of trials. Now I'm going to explain that to you. That's different from theoretical probability. Theoretical probability is the number of favorable outcomes out of the total number of possible outcomes. That's a lot to throw at you here, so let's look at it this way. If you toss a coin 10 times, you should get how many heads and how many tails, okay? This is theoretical probability. You should get 5 heads and 5 tails. I wrote that backwards, but you understand. You should get 5 tails and 5 heads. That's theoretical probability. But let's say you actually toss a coin 10 times. And you get 4 heads and 6 tails. Well, you got 4 heads out of 10 throws. Well, that gives you a 40% experimental probability. So the theoretical probability is what you should get of 50%. The experimental probability is what you actually get. Let's look at another example. You attempt 16 free throws in a basketball game. Your results are shown below, right here. What is the experimental probability of making a free throw? Well, the results were like this. A 0 is a miss, a 1 is a make. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 attempts. And we got 1, 2, 3, 4, 5, 6, 7, 8. We made 8 free throws. That's 8 out of 16, or 1/2, which is equal to 50%. So the theoretical probability, we don't know, because who knows what someone should get whenever they're shooting a free throw. But what we can figure out is what their experimental probability is. And you see this all the time whenever you're hearing about baseball players. Their batting average is .333. Well, what that means is they get a hit once out of every 3 times that they go to bat. So the probability that they're going to get a hit this time is 1 out of 3. Or a basketball player has a free throw percent of 80%. What that means that of all the free throws he's attempted or she's attempted so far, they've made 4 out of every 5, or 80%. Find the experimental probability of getting tails. In 60 coin tosses, 25 of them are tails. So take a moment, pause the video, and see if you understand what we're doing right here, okay? Alright, so the number of tosses were 60, and the number of successes were 25. So it's 25 out of 60, and we want to reduce that, so both of them are divisible by 5. So that gives you 5 out of 12. Did you get that? Did you understand? A bicycle company checks a random sample of bikes. The results are shown. If the trend continues, which is the best prediction of the number of defective bikes in a batch of 1,300? See, this is one of the things it's used for, is that you can figure out what to expect from the quality of your product that you're producing. Because nobody's going to be perfect. It's very seldom that happens, okay? So we want to know what is acceptable when we're producing something. All right, defective bikes were 12 out of 400. So we had 12 defective bikes out of 400 total bikes. And we reduce that, and we get, both of them are divisible by 4, so that gives us 3 out of 100, or 3%. Okay? Now, if they did 1,300 bikes, there's 2 ways to do this, okay? You can take this, okay, and you can go make a proportion, 3 defective bytes out of 100 equals how many defective bytes out of 1300? And so we go 3 times 13, and that gives us 3900 equals 100x. Draw a line, divide by 100 on both sides, and that gives us 39 equals x. Do we see that answer up here? Yes, here it is right here. So we had 12 defective bytes out of 400 that we checked. So if we had a whole batch of 1300, we could expect to find about 39 of them that were defective. The other way to do it, by the way, since we changed it to a percent here, is we could come up here and go to 1300 times 0.03, and 3 times that gives us 3900. 2 decimal places, 1, 2, and that would still give us 39. Well, guess what? It's your turn. Use the information from the last exercise to predict the number of defective bytes in a batch of 3500. Remember the 12 over 400? We reduced it to 3 out of 100. All right, your turn. Take it off. All right, so we got 3 out of 100. So how many out of 3500? So we cross multiply. 3 times 3500 gives us 10,500 equals 100 times x, 100x. Divide by 100 on both sides. And that gives us x equals 105.